All right, calculus. Welcome to your last lesson of the 2020 school year. That's kind of crazy. We are going to be finding volumes using the washer method. Now, technically, this is exactly the same as our disk method. The only thing that's different is now we have a hollow shape, hence washer. So let's try a problem together. It says determine the volume of the solid generated by rotating the region bounded by the following two functions, y equals the cubed root of x and y equals x over 4, that lies in the first quadrant about the y-axis. We probably want to begin by drawing a picture. So I'm going to graph these. Oops. And I am going to scale these 1, 2, 3, 4, 5. That's probably all we need. 1, 2, 3, 4, 5, 6, 7, 8. I'll show you why we need 8 in a moment. Let's start with our line. Y equals 1/4 x. So we know it starts at the origin. It's just a line with a y-intercept of 0 and a slope of 1/4. So up 1 over 4. 1, 2, 3, 4. Up 1 over 4. So we're at the point 8, 2. So we've got this line. Okay, well, that was, okay, I redrew it. It's a little bit nicer. And, okay, so just to reiterate, this is the line y equals 1/4 x. Why are you not writing? There we go. Y equals 1/4 x, and then we need the cubed root of x. Now, if you can't picture this exactly in your mind, maybe plug in a couple points. And hopefully, okay, so if I plug in 0, I take the square root of, or the cubed root of 0, and that's still 0. So I have a point right here. And I'm gonna add that like this. And the other cubed thing I know, well, okay, if I plug in 1, the cubed root of 1 is 1. So I'm going to have a point here. And the cubed root of 8 is 2. Oh, hey, look at that. So I know it's going to look something. This is not going to be perfect, so forgive me, something like that. So y equals the cubed root of x. Okay, so this is our, I'm going to make this a little nicer. This is our shape. And we are taking this shape, this solid that has been generated, this little curvy thingy, and we are rotating it about the y-axis. So we're going around this way. Now, this is, if you can, imagine rotating this around in the shape you would get. I have it under this little thing. I drew this last year when I actually had a smartboard, and it was a little easier. But if I took this curve, now notice that obviously the slant is very different, so pretend the scaling is different. But if I took this little shape and I rotated it around, I would have this weird cone that has a center. So we notice that these little orange things are kind of suggesting I could fall into this. I don't really know what this shape is called, but it doesn't really matter. And we need to find the area of this washer. So remember, we're finding the volume of this entire thing, and the goal is to find little circle areas and then add them all up. So this is what we're going for. We're trying to find the area of this little washer. Okay, so how do we do this? Well, we know a couple things. I think, let's start. We know we need to take the antiderivative and integral. And if we are doing this about the y-axis, so we're going around this way, we're doing this from starting from this point, 0, 0, and ending at this point, 8, 2. But what are our bounds going to be? Because this is with respect to the y-axis, about the y-axis, we're going from low to high on the y-axis, so my bounds are going to be from 0 to 2. And technically I know, since it's with respect to y, this is going to be something dy. Okay? Now I just need to figure out what. If I look back at this picture, what we are going to do is we're going to start by finding the widest radius, so the radius of the big circle, and then we're going to subtract from it the radius of the little circle. So I'm going to start by figuring out what is the wider radius. What is this distance right here? So I'm looking at my line because that's the further from this y-axis. Okay? And it's an x distance, so all I need to do is rearrange this equation to be x equals. How do I do that? Well, I multiply both sides by 4. X is equal to 4y. So 4y is the radius, this bigger radius. Okay? So the area then of the entire bigger circle would be pi times that radius 4y squared. Pi r squared, again, is the area. I'm going to write this down here. The area of a circle with the radius that goes to the line, because that's the wider radius here. Okay, now we need to figure out the area of this little circle in here because we're going to subtract it. So I'm going to actually add the subtraction sign because I know that that's coming. So I need to find this little radius. What is the distance from basically the y-axis to this curve right here? Again, it's an x distance, so I need to solve this equation for x. How am I going to do that? I'm going to cube both sides. So x is equal to y cubed, and that is our smaller radius. So I'm subtracting pi times the smaller radius, y cubed squared. And again, to emphasize, this right here is giving us the area of the smaller circle, the circle with a radius that goes to the cubed root of x. And technically, this is now an easy problem. I mean, maybe it doesn't look easy to you, but I promise it's not bad. We can start by pulling out pi, right? We don't need that in there anymore. And then we're going to have the integral from 0 to 2. I'm also going to simplify this a little. So 4 squared is 16. Y squared minus, what do we do with exponents here? Well, we multiply them. So I have y to the 6th dy. Did not take an antiderivative yet. I'm going to still hold the pi. The derivative, or antiderivative, excuse me, of y squared is going to be y cubed over 3, and I still have that 16. And then I have minus the antiderivative of y to the 6th is going to be y to the 7th over 7. And we are evaluating this from 0 to 2. Because I have a 0 and both of these terms have a y in it, I can kind of ignore that because it's just going to cancel out. So I would technically plug my 2 in for y here, and I would solve. If you want to pause the video and try it, you can. Otherwise, I'm just going to tell you my area is volume is 76.6 units cubed. And honestly, that's it. So really the only difference here is that we're pretty much doing the exact same thing we did in the last section. We just also need to subtract the area of the little circle. So let's generalize this. General formula for this. We are finding the area of, okay. That was supposed to be a circle. Okay, we are finding the area of a washer, meaning we are finding the area of this little donut. And so to do this, we are going to have what we are going to call capital R, or the radius of the big circle, and I'm going to have lowercase r, which I'm going to say is the radius of the little circle. So to find the area of a washer, we are technically taking pi, I'm going to put this out on the outside. The radius of the big circle squared minus the radius of the small circle squared, which means if I want to find volume, remember we need to technically sum up all of these things from A to B. We have pi big R squared minus little r squared, and this is with respect to either x or y, whichever case we are talking about. I'm actually going to stop here for today. I think that's probably enough to get you started, and then next week, Monday, I'll give you another video just practicing a problem, and that's what we got. So Obviously, let me know if you have questions. Have a lovely day.